and thanks for watching.
In this video, you'll learn about two common types of reactions called synthesis and decomposition reactions.
So far in this video series, we've seen how to write chemical reactions and how to balance them, but what about making your own reaction predictions? For example, this reaction between nitrogen gas and solid iodine is percussion sensitive, which means a light tap from that stick is all it takes to cause the reaction to take place, producing this purple cloud of nitrogen triiodide powder. But what about if you weren't told what that product was? Would there be any way that you could make this prediction yourself? Well, as it turns out, there are 5 general reaction types that allow you to do just that, make predictions about reaction products. Those 5 general reaction types are called synthesis reactions, decomposition, single replacement, double replacement, and combustion reactions. And this video is going to focus on just the first 2, synthesis and decomposition. So in synthesis reactions, we have 2 or more types of reactants that combine into one single type of product. Sometimes these are called combination reactions, and in general they look like this. You'll have an A plus a B, 2 separate reactants that combine into one type of product. Those A and B are now attached as one brand new product substance. For each of these reaction types, we can use dancing as an analogy to understand how it works. You can imagine 2 people dancing separately would be equivalent to the A and the B, separate reactant particles. If those 2 people combined and started dancing together, they would be forming one new product like AB. Some real examples of this would be Mg plus O2 combining to make MgO, or SO3 plus H2O combining to make H2SO4. Let's move on to decomposition reactions, which are exactly the opposite. Here we'll have one type of reactant that splits apart into multiple different types of products. In general, they'll look like this. You'll have an AB, there's that one reactant that splits apart into A plus B different types of products. Our dancing analogy in this case would be a set of dancers together, but then for some reason they split apart and are now dancing separately. Some real examples of this could be water splitting into H2 plus O2, or NaHCO3 splitting into 3 new product particles. Now let's apply these 2 reaction types to try and make some predictions about what products might be observed. In this example, I have Al plus F2, and I'm trying to predict what the product of this reaction might be. It seems like it might fit the general formula of a synthesis where you've got 2 separate reactants combining to make one new product. So my prediction for that product is going to be my aluminum simply combining and becoming one new substance with the fluorine. Now there's something really important here I have to point out. My fluorine in the reactants had this subscript of 2. And in the products, I did not transfer over that subscript of 2. It's really important you pay attention to that because your brain kind of wants there to be, if there's a 2 here, there should also be a 2 here. But fluorine, when it combines with aluminum, is a completely new substance. And it's not going to have anything to do with the formula that it had when it was this prior substance, F2. In fact, when you write your new formula, because it is ionic, aluminum is a metal with a +3 charge. Fluorine is a nonmetal with a -1. Technically, to write this new substance's formula, you have to check those ionic charges. +3 -1 balancing out the charge means my new substance should have an AlF3 as its formula. The second reaction, beginning with NH3, seems like it might fit the general formula for a decomposition. I've got one type of reactant, NH3, which is probably going to split apart into separated N plus H, nitrogen and hydrogen elements. That's all you generally have to do for these simple decomposition reactions. The only thing missing here is that nitrogen is a type of element where when it's by itself, it always comes in pairs. They're called diatomic. So the formula for nitrogen by itself has to be N2. Hydrogen is also one of these diatomic elements. So the formula for hydrogen by itself has to be H2. That concludes this video. Here's a brief summary.